Welcome to MRL. In this learning session, we will learn the solutions of exercise 6.2 of the Similar Triangles chapter 10th CBSE textbook. So let us begin. In the first example here, we are given a triangle ABC and DE is parallel to BC. We have to find EC. We have to find AC. Similarly, we have a triangle ABC, DE is parallel to BC. We have to find AD. So let us go one by one. So let us take the first triangle here. In triangle ABC, that is in the first figure, DE is parallel to BC, that is given to us. DE is parallel to BC, it is given to us. AD upon BD is equal to AE upon CE by BPT. That is the basic proportionality theorem. So please learn BPT before attempting these questions, and also converse of BPT. Now AD is equal to 1.5, BD is equal to 3, AE is equal to 1, and we have to find EC, and that is C we have to find. Therefore, cross multiplying it, we get 1.5 into C is equal to 1 into 3, C is equal to 1 into 3 divided by 1.5, and therefore we get C as 2 centimeters or EC as 2 centimeters. Now coming to the second figure, in triangle ABC, DE is parallel to BC, that is given to us. Therefore, AD upon BD is equal to AE upon CE, and that is by BPT, again by BPT, that is the relation we get. And AD upon BD is 7.2, AE is 1.8, and the CE is 5.4. Substituting the values there, AD is equal to 1.8 into 7.2 divided by 5.4, 1.28 into 7.2 divided by 5.4. I have rewritten it because 7.2 was not properly written, and therefore removing the decimals we get 18 into 72 divided by 54 into 10, and that is 24 by 10, and that is equal to 2.4 centimeters. Therefore we have AD as 2.4 centimeters. So these two examples are based on basic proportionality theorem. So let us go to the next example. Now here we are given a triangle PQR. E and F are points on the sides PQ and PR respectively. Now we have to find whether EF is parallel to QR in the following cases. There are different cases given, and we have to show that EF is parallel to QR or not. So let us go to the first case here. We are given P is equal to 3.9 centimeter, EQ is equal to 3 centimeter, PF is equal to 3.6 centimeter, and FR is equal to 2.4 centimeter. And the EF will be parallel to QR if the two ratios, that is PE upon QE and PF upon RF or FR are both equal. So let us see whether they are equal. Now PE upon EQ will be 3.9 divided by 3, that is 1.3. PF upon FR is 1.5. Definitely they are not equal, and since they are not equal, they don't satisfy the converse of BPT, and therefore EF is not parallel to QR. So very simple it is. Now go to the second example. P is 4 centimeter, QE is 4.5, PF is 8, and RF is 9. So let us take the ratio. P by QE is equal to 4 by 4.5, that is 8 by 9, and PF by RF is 8 by 9. Now here the two ratios are equal, satisfies the converse of BPT, and therefore EF is parallel to QR. Now coming to the third example, PQ is 1.28 centimeter, PR is 2.56 centimeter, PE is 0.18 centimeter, PF is 0.36 centimeter. Now taking the ratio PQ upon PE will be 1.28 divided by 0.18, and that is 128 by 18, and PR upon PF is 2.56 divided by 0.36, we get 128 by 18 again. So both the ratios are equal, which satisfies the converse of BPT, and therefore EF is parallel to QR. So this is again based on the converse of BPT. So applying converse of BPT, we have shown which are satisfying and which are not satisfying, and whereby we have shown that EF is parallel or not parallel to the given line. Now coming to the next example, that is example number 3. Here in the figure we are given LM is parallel to CB, LN is parallel to CD. So LM is parallel to CB and LN is parallel to CD. Now we have to prove that AM upon AB is equal to AN upon AD. So let us understand this. In a triangle ABC, LM is parallel to CB, if LM is parallel to CB as it is given to us, then AM upon AB is equal to AL upon AC by BPT. And in triangle ADC here, LN is parallel to CD. That means AN upon AD is equal to AL upon AC. So we have 1 and 2. We have two ratios, equal ratios in 1 and two equal ratios in 2. We find that the RHS AL upon AC and AL upon AC is equal, and therefore equating the LHS we get AM upon AB is equal to AN upon AD, and that is what we wanted to prove. So that is how we prove this particular ratios, showing them to be equal. So learn that. Now coming to the next example, we are given triangle ABC. DE is parallel to AC and DF is parallel to AE. So there are two parallels given here. So DE is parallel to AC and DF is parallel to AE. Now we have to prove that BF upon FE is equal to BE upon CE. So let us see how to do that. Now in triangle ABC, so I have taken triangle ABC here, ABC. Now we have DE parallel to AC, that is given to us. If DE is parallel to AC, then we can apply BPT. Then we get BE upon EC is equal to BD upon AD. BE upon CE is equal to BD upon AD, that is by BPT. So let us call this as 1. In triangle ABE, since FD or DF is parallel to AE, again we can apply BPT to get BF upon FE is equal to BD upon AD. So we have got the equation relation 2 here. Now comparing 1 and 2, we find that BD upon AD is equal. That means RHS is equal. So we can equate LHS. So when we equate LHS, we get BF upon FE is equal to BE upon EC, and that is what we wanted to prove. So that is how we prove, again by applying BPT. So here we have to only just find the triangles, then see whether BPT is applicable, then equate find the two ratios which are equal and equate the other two ratios. So that is so simple, but we have to logically understand and solve them. Now we are given a triangle PQR here in the next example. PQR is a triangle given. DE is parallel to OQ and DF is parallel to OR. We have to show that EF is parallel to QR. So let us understand how to do this. Now let us take the triangle POQ. Let us take it. Now DE is parallel to OQ, that is given to us. DE is parallel to OQ, that is given to us. So therefore, applying BPT, we get PE upon QE is equal to PD upon OD. So let us call this as 1. Now let us take the second triangle POR. In that DF is parallel to OR, and therefore again we get PF upon RF is equal to PD upon OD. So that is 2. Now we find here the RHS PD upon OD and PD upon OD are equal. Therefore equating the LHS, that is P upon QE is equal to PF upon RF. We get this relation. That means now we have proved that P upon QE is equal to PD upon P upon QE is equal to PF upon RF here. Now in triangle PQR, please understand, in triangle PQR we have proved that P upon QE is equal to PF upon RF. That means the line joining E and F, that is the line EF, which is joining the 2 points E and F on the sides PQ and PR of the triangle PQR, is dividing the two sides PQ and PR in the same ratio, that is P upon QE is equal to PF upon RF. That means by converse of BPT, we understand that EF is parallel to QR. So please understand this. So first we have proved the two ratios equal, but these two ratios are the ratios which the line EF divides the two sides of the triangle PQR, that is PQ and PR, are divided into equal ratios, and therefore by applying converse of BPT we find that EF is parallel to QR. So that was what we had to prove here, and we have proved it. Okay, remember that. Now coming to the next example, we are given a triangle PQR. A, B, C are the points on OP, OQ and OR, and AB is joined, therefore AB is parallel to PQ, and AC is parallel to PR. Now we have to prove that BC, the joint BC, is parallel to QR. So let us understand this. Now let us take the triangle POQ. If you take the triangle POQ, we find that we are given that AB is parallel to PQ. If AB is parallel to PQ but natural, OA upon PA is equal to OB upon QB. So let us call this as 1. Now also we are given that AC is parallel to PR. That means OA upon PA is equal to OC upon RC. Okay, that is 2. Now very interesting here, OA upon PA and OA upon P are LHS and both are equal, so I can equate the RHS here. So I have equated the RHS, so therefore I get OB upon QB is equal to OC upon RC. OB upon QB is equal to OC upon RC. See, OB upon QB is equal to OC upon RC. And very interestingly, the line BC, which is joining the points B and C, divides the two sides of the triangle QOR, that is OQ and OR, in the ratio OB upon BQ, OB upon QB, and OC upon CR. But natural, by converse of PPT, BC is parallel to QR. So that is how we have proved that BC is parallel to QR. So BC is a line which divides the two sides of triangle QR in the same ratio, that is the ratio here which we have proved, and therefore BC is parallel to QR by converse of BPT. So please remember the method. So here the examples are solved using the BPT, that is basic proportionality theorem, and the converse of BPT, and if you are thorough with these two important theorems, then solving examples becomes very easy. Now coming to the next example, to prove converse of midpoint theorem. We had learned midpoint theorem maybe in the 9th grade, that is CBSE 9th textbook, that was the old textbook there. Now the converse of midpoint theorem is, it states that a line drawn through the midpoint of one side, of a triangle parallel to another side bisects the third side. Now what does that mean? So let us say we are given a triangle ABC, D is the midpoint of AB, D is drawn parallel to BC, then D will bisect the third side AC such that E is the midpoint of AC, or E is equal to CE. So now here we have to prove that AE is equal to CE. So let us understand how to prove this. In triangle ABC, D is parallel to BC. If D is parallel to BC, then AD upon BD is equal to A upon C, and that is by BPT, it is correct. But D is the midpoint of AB, that means AD and BD are equal, and therefore the LHS here, AD upon BD becomes AD upon AD and equal to A upon C, and that is 1 is equal to A upon C, or AE is equal to CE. So that is what we had to prove, and it is so simple proof here. Otherwise we had to go a long way to prove this in the 9th grade with different methods. This is the proof of the converse of midpoint theorem on the basis of the similarity of triangles, or on the properties of similarity of triangles. A very easy method. Try to remember and learn. Now coming to the next one, that is to prove midpoint theorem. Again, if we have to learn how to prove the midpoint theorem, we had learned midpoint theorem again in 9th grade. So now the method of proving there was different. Now that was based on quadrilaterals, parallelogram and all that. Now here we are going to prove this by using the properties of similarity of triangles. Let us see how it is and what it is. The midpoint theorem states the line joining the midpoints of any two sides of a triangle is parallel to the third side. That means D is the midpoint. DE is D is the midpoint of AB, E is the midpoint of AC, and D is joined. Now once D is joined, we have to prove that D is parallel to BC. So let us understand here. So we are given a triangle ABC. D and E are the midpoints of AB and AC. D is a line joined. D and E is joined, and therefore it's a line. And we have to prove that D is parallel to BC. So let us understand. In triangle ABC, D is a line which divides the two sides AB and AC in in the ratio AD by BD and AE by CE, but we know that AD by BD is 1 and AE by CE is also 1. So we have AD by BD as 1 and AE by CE is 1 because AD is equal to BD, AE is equal to CE. It means that AD upon BD is equal to AE upon CE, and that DE is dividing the two sides of the triangle ABC in the same ratio. Two sides are divided in the same ratio, but natural, it is DE is parallel to the third side, that is BC, by BPT. Therefore the line D divides the two sides in the same ratio, therefore D is parallel to BC by converse of BPT. So therefore remember, such a simple way of proving it. Otherwise we had to prove this theorem, midpoint theorem, in 9th grade by going to 3 or 4 steps, and their method was different. This is a simple method on the basis of similarity of triangles. Learn it and remember. Now coming to the next example, we are given a trapezium here, ABCD, and AB is given as, of course, parallel to DC, but naturally it's a trapezium, therefore AB is parallel to DC. There are two diagonals, AC and BD, they intersect at point O. Now we have to prove that AO upon BO is equal to CO upon DO. So let us understand how to prove this. Now here we require a construction, so let us see what is the construction here. Draw OE parallel to CD. So I have drawn OE parallel to CD. Now if OE is parallel to CD, then AE, so if you take the triangle here, please understand, let us take the triangle ACD, then AE upon DE is equal to AO upon CO by BPT. Taking the triangle ACD, we can apply BPT, so we got AE upon DE is equal to AO upon CO. Now let us take the triangle, another triangle ABD. Again OE is parallel to AB, therefore AE upon DE is equal to OD upon OB, or BO upon OD, correct? So now we have got two equations, two relations here. Now from 1 and 2, what we find that AE upon DE and AE upon D, that is LHS, are equal. So equating the RHS, we get AO upon CO is equal to BO upon DO. So when I cross multiply and rearrange it, I get AO upon BO is equal to CO upon DO, and that is what is expected of us to show, and we have shown that these two ratios are equal. A very simple method with a simple construction, we have proved it. So try to remember and learn it. Now let us solve the example number 10 here. That is, we are given a quadrilateral ABCD. Diagonals AC and BD intersect each other at point O, such that AO upon BO is equal to CO upon DO. AO upon BO is equal to CO upon DO. Now we have to prove that quadrilateral ABCD given to us is a trapezium. So for that, let us do a construction. Let us draw OE parallel to CD. OE parallel to CD. If OE is drawn parallel to CD, then in triangle ACD, AE upon DE is equal to AO upon CO by BPT. Now AO, but what is given is AO upon BO is equal to CO upon DO. AO upon BO is equal to CO upon DO. If I rearrange them, then it will be AO upon CO is equal to BO upon DO. But in one we have AO upon CO is equal to A upon ED, and AO upon CO is equal to BO upon DO. That means the AO and CO are equal here. So I can equate AE upon ED as equal to BO upon DO. But what is AE and DE? AE upon ED. AE upon ED is the side of the triangle ABD, and also BO upon DO. BO upon DO is the other side of the same triangle ABD. That means the line joining, that is OE, which is the line joining the two sides of the triangle ABD, that is side AD and BD, has divided the two sides in the same ratio, that is AE upon ED is equal to BO upon DO, and by converse of BPT, OE becomes parallel to AB. So OE is parallel to AB, we have proved, and OE is also parallel to CD, and therefore AB is parallel to CD, and therefore ABCD is a trapezium. So that is how we have proved this given example. So learn this method of proving the examples, applying BPT, converse of BPT, and all the basics of the similarity of triangles. Learn them, okay, practice them, and note all these examples in a book for your future reference. Okay, thank you.